the opportunity, I will speak about stationary fuel cells again and methane fuels and not hydrogen fuel cells. I'm short introduction about myself. I'm in this industry now. I've been here for about 5 years, almost 6 years now. I come from the automotive industry originally, and during these last 5 years, this industry of fuel cells, especially for the stationary applications, went really through a major transformation. If you were here 5 years ago, maybe many of you were here 5 years ago, you would have listened to presentation about durability, performance, technologies. Now you're here. I'm very pleased that I'm not the only one. Actually, I'm one of the company who is speaking about products, how fast this product will reduce their cost, how fast these products will go into mass production. It's really a radical change of what the producer and manufacturer of fuel cell companies are presenting today. Now, as we have only 10 minutes, I will try to be quick and give you an overview of the company SOFC Power. We produce high efficiency generators, and which convert natural gas into electricity and heat for residential and commercial applications. Our focus market is the residential cogeneration, which is the micro CHP, micro combined heat and power, in the kilowatt size. You have heard today that many other applications are possible, larger systems with hundreds of kilowatt up to the megawatt, and even large power plant of more than megawatt. We are focused on developing and producing low-cost products, having a low-cost strategy from the beginning, dipping a lot into the automotive approach that we've been following always, to achieve the grid parity, because that's all what it counts. I agree absolutely. There is no need to compare one fuel cell technology to the other. We all compare to what exists today, which is the grid. And we all want to achieve the grid parity at a certain production volume. Now this is the number that counts, and I'm also very pleased to see that the number you have seen today all converge, that no gigawatts production are needed, but let's say 50 megawatts per year production capacity are sufficient for this technology to achieve grid parity, even without subsidy. Just to put it in a context, every utility making a decision to build one power plant, they speak about hundreds of megawatts. The smallest Siemens gas turbine is 250 megawatts, what they're selling today, for central power generation. So a decision of building in this case, a virtual power plant of 50 megawatt is actually a small power plant for a utility. And that's sufficient to make this technology competitive. We are based in Switzerland, where we have acquired a technology, and we produce in the north of Italy. So we are all in the Alps. There we have a 2 megawatt per year production facility, pilot production facility with manufacturing equipment. We are not in a lab, we are in a production unit. We've been testing micro CHP units since 2009. The units for the European rollout are undergoing certification, which is not yet completed. We plan to install those units in 2013. We have, as I said, a pilot production unit currently in production. We have produced hundreds of stacks, thousands of cells, and several systems. The production processes to set up a production unit up to or even higher than, but we have chosen a size of 50 megawatt per year, is ready. We know the process. Of course, we have to scale it up, and this will take us into 2015. The target market, as I said, the first focus market is the European micro CHP, meaning more precisely Germany, even the UK, Belgium, Holland, and many other countries to come. The strategy of commercialization, also no surprise here, utilities are a key partner to achieve volumes in a quicker than selling these systems one by one. So we do have partnership with utilities to roll out our products. I think you heard it enough today. everybody basically said that all key factors that are needed are finally aligned for the micro CLP application. Combined heat and power delivers, those are units that can deliver and delivers efficient and competitive electricity and heat for a variety of applications. The regularity environment is very favorable, probably has never been so favorable to these applications. And starting from Japan, they've always been the first in this area. Afterward in Europe, the first in Europe had been Germany. It's also not a surprise. And now Korea is very, very aggressive in this field with their goals. And the USA are really getting more and more attention on this subject because of the evolution on the gas price. Gas price is going down in the US and electricity price is going up. Performance, as I said before, 5 years ago you would hear presentation about how the fuel cells will meet the performance. Now you have seen in the last 5 years several national programs, again starting from Japan and in Europe and in several other countries. We have shown that these systems meet the customer requirements. Costs, I will of course say much more about the cost. The technology we have chosen has no precious metal, is based on low-cost materials. They are advanced ceramic, but no exotic materials, no strategic materials. So they are low-cost materials, and also, as important as materials, low-cost manufacturing processes. Today, I should actually be in Brussels. Today, there is the kickoff of the NFILD program. It is the European rollout program, which involves several utilities, fuel cells and boiler manufacturers, and other institutions. It's one of the largest European programs today. And what it does is the rollout of this technology, the field testing of thousands of these systems through the next 2 years. I prefer to come here today because they are already convinced, so they're starting the project, so that's why I'm talking to you. These are some pictures of our integrated products that has been exposed in exhibitions this year. On the left side, you see a wall hung unit, actually two. So our fuel cells, our hot boxes, can be integrated in wall hung system and also floor standing unit. For the NFILD program, for the European rollout, we have chosen to roll out a floor standing unit that we are manufacturing together with our partners. How do we get to volumes? The path is always the same. You have seen it in different forms, different tastes all over the day today. Especially utilities, they do initial trials. They test a couple of systems. They see how they work. They check the economics with the CFOs. They take the decision, okay, we like it, and it works, and we can make money out of it. After that, they've done this one, they go to the next phase, which is extensive tests. Never try to rush a utility. It's not possible. They make their tests of tenths of unit or even 100. This phase, it takes 1 to 2 years. Some people want 1 winter, some people want 2 winters. This is the phase that we're doing today. And after that, you can say, if it passes those 2, then we will roll out. We can buy 10,000 of them. That's the standard rollout. SOC Power is in this process, in the second phase, which is represented by the European NFILD program. We have received utilities order. We are participating in rollout programs where at the end of the program there is a deployment of more than 10,000, about 30,000 units. So what we have in front of us is the production, the ramp-up of production. Of course, marketing and promotion activities. That's the difference between making 1 power plant and installing 10,000. There is more people to talk to. And these are some basic numbers, and I will give you more in detail in bilateral talks, if you would like. 2015, that means 2 years from now, is the year when we can talk volumes. It takes 2 years to ramp up a production. It takes also more than 2 years to build a power plant. So we are not slower or not faster than building a normal power plant. Now, what is the price of these boxes, as the utility calls them? It depends on how many you order, like any other products, from the supermarket to phones to any other things. Today, if you order, let's say, 1 to hundreds of units, the prices are in the 10,000. And that's the prices of, let's say, prototypes and field test units. If you order more than 1,000 units, the price that's the price of the selling price of SOFC power to anybody placing such an order, to be precise. We go between 10,000 and 5,000. Above 10,000 units, we can commit to a price of below 4,000, of course, and we can negotiate what that price can be. And as I said before, the delivery of those 10,000 units will take me 2 years to do it, because I have to ramp up production to do it. What tells me, or tells you, that this is possible? And there are several ways to do it. One is to show experience curves, also from other industries, but I've chosen to do it in a different way. As I said, in my past, there is automotive industry. I've been even a buyer in the automotive industry, what doesn't do for a living. But I was buying technology, so I know what supplier quote is, and I've chosen to show you actual supplier quotes. Of course, don't ask me to show you the bill of material with all the supplier names and what they quote for the components, but I've chosen to show you a couple of key numbers. One is that in the stack, which is the most innovative part of the fuel cell, there are about 100 euro material cost. So with 100 euro per kilowatt, we buy the material to produce one stack, 1 kilowatt. Of course, if I order the material to make 20,000 units. But this I can do today. These are not extrapolations. These are quoted I have today. Now about, these are the material price. What about other key stack components? These are the prices I have today. If I order for 100 unit, I have a certain price. If I order for 1 megawatt at that price, 10 megawatt that price. I just have to place that order. It's not that I have to develop anything, not the supplier has to set up a production plant. Third example, going in the BOP components, is the same story. These are real numbers, are not some extrapolation that I do. If I order 100 units, that particular component costs me 80 per kilowatt. 50,000 units, it costs 20. You see two things. One is that the numbers are low in absolute value. In the slide before, you have seen prices in the order of magnitude of thousands. Here you see components that cost hundreds. I can show you many more details if you come and see what we are doing, but you can see that this is actually feasible. Now, to conclude and leave room for discussion, at the maturity level the technology is today and the products are today, the visibility of the market, which means having enough confidence that the volumes, that the order will come, is the key for major short-term supply chain cost reduction. The time to ramp up a production is, like in any industry, it's about 18 to 24 months. And we have signed agreements that show us this confidence, that we have these numbers and we have this volume, and we can start to do that. SOFC Power is a privately owned company, has been funded by an industrial, is a private owned, it's an owner of an industrial group in north of Italy. He's in several industrial businesses. He has invested about 30 million until now in this company. And we are looking for an investment round at about, say, 20, 25, 30 millions to get to fund our program. And of course, we are looking for also industrial partnerships, but I think the financing part is the one more relevant to this audience. Thank you very much.